Hi, hello everyone. Welcome to SK Academy of Mathematics. Today, let us learn how to solve the rotational and scalar function, one of the most important asked repeatedly in the VTU main examination. How to simplify and how to reduce this? Now, let us see. First, let us find what we need to find. First, we need to find irrotational. What do you mean by irrotational? If curl vector f equal to 0, then we call it as irrotational. That is, first, let us represent the given solution. Given vector f which is equal to y plus z I cap plus z plus x j cap plus x plus y k cap. First we need to show that it is irrotational. So we need to show irrotational means curl vector f excuse me, should be equal to 0. What is curl vector f? Determinant of I j k 2 by 2x 2 by 2y 2 by 2z f1 f2 f3. What is f1? Where f1 represent y plus z, f2 represent z plus x, f3 represent x plus y. Now substitute in this given determinant, that is curl vector f which is equal to I j k 2 by 2x 2 by 2y 2 by 2z. What is f1? Y plus z, z plus x, x plus y. Now do the determinant matrix multiplication, that is I into 2 by 2y into x plus y minus 2 by 2z into z plus x minus j into 2 by 2x into x plus y minus 2 by 2z into y plus z plus k into, that is 2 by 2x into z plus x minus 2 by 2y into y plus z. Done? Yes. Now let us differentiate term by term. Curl vector f which is equal to, what is curl vector f? I need to differentiate term by term. Now see, first I need to differentiate this whole term. Now in the first term we don't have y, so this term becomes 0. 0 plus differentiation of y with respect to y is 1 minus, now I need to differentiate with respect to z. Differentiation of z first term with respect to z is 1 plus differentiation of x with respect to z is 0, because we don't have the term with respect to z, so that becomes 0 minus j into differentiation of x with respect to x is 1 difference plus differentiation of y with respect to x is 0 minus differentiation of y with respect to z is 0 plus differentiation of z with respect to z is 1. Next we have plus k into, now let us differentiate, differentiation of z with respect to x 0. Next plus differentiation of x with respect to x is 1. What the point? Minus differentiation of y with respect to y is 1 plus differentiation of z with respect to y is 0. What you get? Curl vector f which is equal to I into plus 1 minus 1 minus j into plus 1 minus 1 plus k into plus 1 minus 1. 1 plus 1 minus 1 plus 1 minus 1 get cancelled. Curl vector f which is equal to 0. If curl vector f is equal to 0, therefore the given vector field is irrotational, is irrotational. Got the point? How to find irrotational? Yes. Now, then next also find scalar function phi. Now we need to find scalar function phi. Whatever we find scalar function phi, if I differentiate or if I find vector f also, I need to get the same function. Okay, that is, see, first let us find what they have given scalar function phi such that consider the given, that is gradient phi which is equal to vector f. What is gradient phi? We know that dou phi by dou x I cap plus dou phi by dou y j cap plus dou phi by dou z k cap, which is equal to, what is vector f? We have y plus z I cap plus z plus x j cap plus x plus y k cap. Now differentiate, no, separating the term with respect to given direction I j k, that is dou phi by dou x which is equal to y plus z. Next dou phi by dou y which is equal to z plus x, dou phi by dou z which is equal to x plus y. Now just I need this scalar function. What do you mean by scalar function? That is scalar function is phi. So what I'm going to do, I'm going to represent this as equation 1, represent this as equation 2 and represent this as equation number 3. Now consider equation number 1, consider equation number 1. Okay, that is dou phi by dou x which is equal to y plus z. Now I need the function only phi, so what I am going to do, integrating on both sides. When you integrate, integration differentiation get cancelled with respect to x, only the function remains same, that is integral dou phi by dou x which is equal to integral y plus z into, with respect to which function I am going to do, dx plus what is the constant function? The constant function is f1 of y comma z. Since I am differentiating with respect to x, y and z will be the constant function. Now phi, differentiation and integration get cancelled. Split the terms, that is integration of y with respect to dx plus integration z with respect to dx plus f1 of y comma z. Got the point? Now p which is equal to y remains constant, integration of 1 dx plus z remains constant, integration of 1 dx plus f1 of y comma z. Phi which is equal to y into differentiation of 1 with respect to dx x plus z into differentiation, integration of 1 with respect to dx, we have x plus f1 of y comma z. This will be our first. Similarly, let us go with the second, that is consider equation number 2, that is dou phi by dou y which is equal to z plus x. Again integrate on both sides, integral dou phi by dou y which is equal to integral z plus x dy. Now I am going to integrate with respect to dy. So f2 function will be constant with respect to z comma x. Now integration differentiation get cancelled. Phi which is equal to integration of x dy plus integration of x dy plus f2 of x comma z. Similarly, now I am going to write directly z remains constant, integration of 1 with respect to dy y plus the x remains constant, integration of 1 with respect to dy y plus f2 of x comma z. This is the another scalar function. Now the last consider equation number 3, that is dou phi by dou z, which is equal to, what is equation number 3, x plus y. Integrate on both sides, integral dou phi by dou z, which is equal to integral x plus y. Since I am going to integrate with respect to dz plus f3 will be constant on x comma y. Integration differentiation get cancelled, phi which is equal to integration of x dz plus integration of y dz plus f3 of x comma y. Phi which is equal to xz plus yz plus f3 of x comma y. Now we have three scalar function with respect to x, y, z. I am going to consider the function that is phi, but I need the only one single function. How? Now let us see. First, compare equation. Consider this as equation 1, equation 2, and equation 3. This is simple. How? Now let us see. First, we have yx or xy. In the first term, we have xy. In the second term, we have xy. We have xy in the third term? No. This is simple. How? In which scalar function has which, for example, if we have yx, we have yx. But here we don't have yx. So what we are going to do? We are going to consider f3 of x comma y, which is equal to xy, so that it satisfies, well, which in this equation number 3. Now let us go with the second one. Zx, yes we have. Zx, no we don't have. Here we have xz. Zx and xz both are same, but where we don't have xz in the equation number 2. So what we are going to give? f2 of x comma z, which is equal to zx. Got the point? Yes. Similarly, now in the we need to find f1. We have zy. Here we have zy. Here we have zy. No, we don't have zy. That is f1 of y comma z, which is equal to zy. f1 of y comma z, which is equal to zy. That is xy plus xz plus yz. This is our scalar function. See, why we have considered this constant function, so that it satisfies all the scalar function. If I give yz, that is yz, see I have xy, yes, xz, yes, yz, where it satisfies the first scalar function. If I give for f2 of z comma x, if I give xz, see xy we have, sorry, zy we have, next xy we have, zx if I give, equation 2 also satisfied. Now equation 3, if I give xy, we have xz, yes, we have yz, if I give xy, equation 3 also satisfied. That means whichever the scalar function has not, whichever don't have the constant function, we are going to give that function and satisfy the scalar function. This is how we are going to find the scalar function. Okay, I hope you have understood how to solve, how to find irrotational, that is if the curl vector f is equal to 0, that we call it as irrotational. Then how to find scalar function, this is how we are going to find the scalar function. One of the most important question which been asked for VTU main examination. I hope you have understood this problem. For more videos, please do like, share and subscribe. See you in the next video. Thank you.